The goal in section 5.5 is to write an equation of a line in slope-intercept form when it's parallel to a given line, and also to write an equation in slope-intercept form when it's perpendicular to a given line. The main thing that we really need to remember this year about parallel lines, we already know they are lines that never intersect, but the thing that's really important is that they have the same slope. The symbol for parallel lines looks like absolute value bars. So here's a situation where we're going to write an equation of a line with the given information. So I'm going to try to color code to help this situation out. So the line that we actually want to write in slope-intercept form passes through the point -3, -5. But we also know that it's parallel to the line y equals 3x minus 1. So if you can kind of picture on a graph two separate lines. One line is blue, that's the y equals 3x minus 1. And one line is red, and we know that it passes through the point -3, -5. We also know that these two lines are parallel. So we know on the blue line, since the equation is y equals 3x minus 1, that the slope of the blue line is 3. Since it's written in slope-intercept form, and 3 is the coefficient of x, then 3 is the slope. Because we know that the red line and the blue line are parallel to each other, then that means that I also know that the slope of the red line must also be 3. So now I have enough information to write the equation of the red line. I know that it has a slope of 3, and I'm also told that it passes through the point -3, -5. So with that, I can set up the way I have always set up my equation. Y equals mx plus b. I can replace y with -5 from the ordered pair. I can replace m with 3. I can replace x with -3 from the ordered pair, and then plus b. So even though on the blue line, the y-intercept of the blue line is -1, that's irrelevant to whatever the y-intercept of the red line is going to be. The only thing we need from the blue line is that the slope is 3. That's what's really important to us. So now for the red line, I can solve this like normal. So I have -5 equals -9 plus b, which means that b is 4. And then to complete the equation, I would have to plug both m and b back in. So this, as a final answer, would be y equals 3x plus 4. So essentially, you just need to steal the slope from the line that it's parallel to prior to writing the equation. So once you have the slope, then you have the slope and one of the points that it's going to pass through. Try these two examples, pause the video, press play when you're ready to check your answer. So for this example here, my goal is to write the equation of the black line, which I know passes through the point -2, 11. The thing that I need to know about the black line before I can continue is what is its slope. To do that, I know that it's parallel to the blue line, and the blue line is written in slope-intercept form, and the blue line has a slope of -1. Parallel lines have the exact same slope, so that's also going to be the slope of my black line. If I plug in 11, -1 for the slope, -2 for the x, I can solve for b, and I got b equals 9. I just came down here to write my answer. Y equals -1x plus 9. That could also be written as y equals -x plus 9. You don't really need the 1, you just need the negative sign. The next example was just slightly different, so we're trying to write the example of the blue line. So we have an x and a y coordinate. What we're missing is the slope. We know that it's parallel to the green line. The difference here is that we can't quite identify the slope of the green line yet because it's not written in slope-intercept form. It's actually written in standard form. So the first thing I'd have to do is put it in slope-intercept form by isolating y, and to do that I'm minus 2x. Once I've done that, the slope is actually -2. That's really important. So now that the slope of the green line is -2, that means that the slope of the blue line is also -2. So now I can plug in all of my information. And I got y equals -2x minus 3. In the past, the thing that we've known about perpendicular lines is that they intersect at right angles. The thing that's going to be important about perpendicular lines this year is that their slopes are opposite. That means if one's positive, the other's negative, or if one's negative, the other's positive. So they're going to be opposite reciprocals. So for example, if a blue line had a slope of -3/4 and the red line was perpendicular to it, it would have a slope of positive 4/3. So it changes from negative to positive, and it also flips. So on the examples down here, we're going to see if any lines are parallel or perpendicular, and we're going to actually do that by identifying the slopes. So on the first example, A is already in slope-intercept form, which is great, because then we can just say what the slope is right away, which is 5. On both B and C, the first thing that we'd have to do is put them in slope-intercept form. So to put B, we'd minus x. So we get 5y equals 2 minus x, and then divide by 5. I'm really not even interested in the y-intercept because it doesn't matter. And you can see the slope is negative 1/5. So I'll put that up here. And then I'd have to do the same thing for line C. To do that, I would add 2x. I'm just going to skip a few steps to save room. And then divide by negative 10. So this slope would also be negative 1/5. So because B and C have the same slope, they both have a slope of negative 1/5, I could say that B is parallel to C. No, this isn't really where it should go. And then if you look at red has a slope of 5, positive 5. Green has a negative slope, and it's also the reciprocal. So the reciprocal of 5 is 1/5, and they're opposites because red is positive and green is negative. So I can also say that line A is perpendicular to line B, but then A and C are also opposite reciprocals, so A is also perpendicular to C. Try both 2 and 3. Pause the video, press play when you're ready. So in both of these examples, they actually just coincidentally had the same answer. On 2, it's already in 2a, it's already in slope-intercept form. The slope is negative 3. This one, you just add x, divide by 3, you get a slope of 1/3. Here you minus 2x, divide by, that should have been a negative 6, my apologies. So that should actually be a positive 1/3. So B and C have the same slope, so in number 2, B and C are parallel. And then negative 3 and positive 1/3 are opposite reciprocals, so A is perpendicular to B, A is also perpendicular to C. Again, that should have been a positive 1/3 because I should have divided by negative 6. 3a minus 2x and then divide by 6, you get a slope of negative 1/3. B, it's in slope-intercept form. The slope is 3, which is the opposite reciprocal. That means A and B are perpendicular. C, you would minus 4.5x and then divide by negative 1.5, which comes out to 3. So B and C are parallel. They have the exact same slope. A and B are perpendicular. They're opposite reciprocals. A and C are also opposite reciprocals, so they are also perpendicular. So now we're going to do the same thing that we actually did on the previous page, but instead of the line given being parallel to the line we want, it's going to be perpendicular. So again, I'll try colors. So I want to write the equation of the blue line, which is passing through the point 4, negative 5. So I have an x and a y. If I had a slope, I would be able to find b. So as long as I can find a slope in some way, I'm going to be good to go. So this time the symbol says that it's perpendicular to the line y equals 2x plus 3. So the thing that I want to steal from this red line is its slope. And since it's in slope-intercept form, I can do that. So the slope of the red line is 2. But when I bring that over here, because they're perpendicular, they're not going to be exactly the same. The slope of the blue line is going to be the opposite. It's positive, so it'll be negative, reciprocal, which is 1/2. So when I use the slope of the blue line, I need to use that the slope is negative 1/2. And I'm also going to use 4, negative 5. I'm just going to come over here so I have some room. I'll write that ordered pair, 4, negative 5. So now if I plug into y equals mx plus b, now I can solve for b. Again, the original y-intercept of the red line was 3, but it really doesn't matter. The only thing that matters is the slope. The slope of this line was 2, so the slope of the blue line is the opposite reciprocal. Now I have enough information to figure out what b is. And in doing that, I get that b is negative 3. So then y equals negative 1/2 x minus 3. This one's a little bit trickier because you have to make sure that when you're doing the math here, you're putting in the correct slope, that you're using the opposite reciprocal, and when you're doing your final answer, you put in the correct slope, the opposite reciprocal. When they were parallel, it was a little easier because they were exactly the same, so if you picked the wrong one, it really didn't matter. So here I'm going to write the equation of the red line that's passing through the point 4, 3, and it's also perpendicular to y equals 4x minus 7. So we know the slope of the black line is 4, which means that the slope of the red line is going to be negative 1/4. So you're going to finish this problem here with the information I've just given you, and then you're going to try this example right here. Pay close attention to the format of the line that they give you, the form that it's written in. Be careful before you start that you identify the slope correctly. Pause the video, press play when you're ready. So once we take negative 1/4 and put it in the place of the slope, 4 takes the place of x, 3 takes the place of y. Solve for b, you get 4. So then y equals negative 1/4 x plus 4. Just, again, be sure to put in the correct slope in your final answer. Put in the slope of the line that you're working on, not the slope of the original line. On this one here, we need to first find the slope of the green line, but before we do that, we have to put it in slope-intercept form. So the first thing you actually have to do is add 4x to both sides. When you do that, then the slope of the green line is 4, which makes the slope of the blue line negative 1/4. That's the slope I use when I plug in x and y. Solve for b. Y equals negative 1/4 x minus 1.